Look around you. Everything you see, from the chair you're sitting on to the air you breathe, is made of atoms. These tiny particles are the fundamental building blocks of matter, the Lego bricks of the universe. Atoms are so small it's almost impossible to imagine their size. A single grain of sand contains billions upon billions of atoms, yet despite their infinitesimal size, atoms hold the key to understanding the vastness of the cosmos and the intricacies of life itself. From the fiery heart of a distant star to the delicate petals of a flower, atoms are the common thread that weaves together the tapestry of existence. Their story is a journey into the heart of matter, a quest to understand the fundamental ingredients that make up everything we know and love. So, what exactly is an atom? It's a question that has fascinated scientists for centuries. Imagine the smallest thing you can possibly conceive of, a speck of dust, a grain of pollen, even a single cell. These are already incredibly tiny, almost beyond the reach of our naked eye. Now shrink that object down millions of times. It's hard to even imagine, but this is the scale we're talking about when we discuss atoms. You're getting closer to the realm of atoms. These are the building blocks of everything around us, from the air we breathe to the stars in the sky. Atoms are the smallest unit of an element that retains the chemical properties of that element. They consist of a nucleus made of protons and neutrons, surrounded by a cloud of electrons. In other words, an atom of gold is still gold, even though it's incredibly tiny. This tiny particle still has all the characteristics that make gold, well, gold. This incredibly small size is what makes atoms so difficult to study, but also so fascinating. Scientists use advanced tools and techniques to observe and understand these minuscule particles. Their minuscule scale means that atoms behave in ways that defy our everyday intuition. They don't follow the same rules as larger objects that we can see and touch. They operate according to the laws of quantum mechanics, a branch of physics that describes the strange and often counterintuitive behavior of particles at the atomic and subatomic levels. In this quantum world, particles can exist in multiple states at once, a phenomenon known as superposition, and where energy comes in discrete packets called quanta rather than being continuous. Understanding atoms requires us to embrace a new way of thinking about the universe, one that is often at odds with our everyday experiences. It challenges our perceptions of reality and invites us to explore the mysteries of the quantum world, where the rules are different and the possibilities are endless. While incredibly small, atoms are not the smallest things in the universe. They are composed of even tinier components that play crucial roles in the fabric of reality. Zooming in even further, we encounter the subatomic particles that make up an atom. These particles are the fundamental building blocks of all matter. At the center of every atom lies a nucleus, a dense core composed of two types of particles, protons and neutrons. This nucleus is incredibly small, yet contains nearly all the mass of the atom. Protons carry a positive electrical charge, while neutrons carry no charge, making them electrically neutral. The balance of these particles is essential for the stability of the atom. These particles are bound together by a powerful force known as the strong nuclear force, one of the four fundamental forces of nature. This force is what keeps the nucleus intact, despite the repulsive forces between positively charged protons. Orbiting the nucleus is a cloud of even tinier particles called electrons. These electrons are much lighter than protons and neutrons and occupy a vast region around the nucleus. Electrons carry a negative electrical charge, and they are constantly in motion, whizzing around the nucleus at incredible speeds. Their rapid movement creates a cloud-like region that defines the atom's size and shape. The number and arrangement of these subatomic particles determine the chemical properties of an atom, dictating how it will interact with other atoms and form the building blocks of matter. This intricate dance of particles is what gives rise to the diversity of elements and compounds that make up our world. The subatomic particles within an atom don't just sit idly by, they are engaged in a constant dance, governed by a delicate balance of forces. These forces are what hold the atom together and prevent it from flying apart. As mentioned earlier, the strong nuclear force binds protons and neutrons together in the nucleus. This force is incredibly strong, overcoming the natural repulsion between the positively charged protons. But there's another force at play, the electromagnetic force. This force governs the interaction between electrically charged particles. In the case of an atom, the positively charged nucleus attracts the negatively charged electrons, keeping them in orbit. These forces, working in tandem, are crucial for the stability of atoms. Without them, the building blocks of matter would disintegrate, and the universe as we know it would cease to exist. Atoms come in a variety of flavors, each with its unique set of properties. These variations arise from the number of protons, neutrons, and electrons within each atom. The periodic table, that iconic chart found in classrooms and laboratories worldwide, organizes these different types of atoms, known as elements. Each element is defined by its atomic number, which corresponds to the number of protons in its nucleus. From the simplest element, hydrogen, with its single proton, to heavier elements like gold and uranium, the periodic table is a testament to the diversity of matter in the universe. Each element on the periodic table has a story to tell, a unique combination of properties that determines its place in the grand scheme of things. Section 6. Molecular bonds, atoms joining hands. Atoms are social creatures, constantly interacting with one another to form larger structures. These interactions are the basis of chemistry, the study of how matter transforms. Atoms can bond together to form molecules, which are two or more atoms held together by chemical bonds. These bonds arise from the sharing or transfer of electrons between atoms. There are different types of chemical bonds, each with its own strength and characteristics. Covalent bonds involve the sharing of electrons between atoms, while ionic bonds occur when one atom donates an electron to another. These molecular bonds are essential for the formation of everything from water molecules, which sustain life, to complex proteins, the workhorses of our cells. The way atoms bond and interact determines the properties of the substances they form, shaping the world around us. Section 7. Atoms in action, from stars to smartphones. The influence of atoms extends far beyond the realm of chemistry labs and textbooks. They are the unsung heroes of countless natural phenomena and technological advancements. Inside the fiery core of stars, atoms undergo nuclear fusion, a process where lighter elements combine to form heavier ones, releasing immense amounts of energy in the process. This stellar alchemy is the engine that powers the stars and the source of all the elements heavier than hydrogen and helium in the universe. Atoms are also at the heart of many modern technologies, from the semiconductors that power our smartphones and computers to the lasers used in telecommunications and medicine. Our ability to manipulate and control atoms has revolutionized the way we live, work, and interact with the world. Section 8. The future of atomic understanding, unlocking new possibilities. Our journey into the world of atoms is far from over. Each day, scientists uncover new layers of complexity and wonder within these tiny building blocks of matter. Scientists continue to delve deeper into the mysteries of the atom, pushing the boundaries of our understanding and unlocking new possibilities in the process. Their relentless pursuit of knowledge is driven by the potential to transform our world in ways we can only begin to imagine. Nanotechnology, the manipulation of matter at the atomic and molecular level, holds the promise of revolutionizing fields like medicine, materials science, and computing. This cutting-edge technology allows us to create materials and devices with unprecedented precision and functionality. Imagine tiny robots that can deliver drugs directly to cancer cells, targeting them with pinpoint accuracy while minimizing side effects. These nanobots could navigate through the bloodstream, seeking out and destroying harmful cells with remarkable efficiency. Or consider super-strong materials that are lighter than a feather, yet stronger than steel. These materials could revolutionize industries from aerospace to construction, making everything from airplanes to skyscrapers safer and more efficient. Quantum computers, which harness the strange laws of quantum mechanics to perform calculations at speeds unimaginable with current technology, are another exciting frontier in atomic research. These machines have the potential to revolutionize computing by solving problems that are currently beyond our reach. These computers have the potential to solve problems that are currently intractable, such as designing new drugs, breaking encryption codes, and modeling complex systems. The future of atomic understanding is bright, filled with endless possibilities that could reshape our world in ways we have yet to fully comprehend. Section 9. Conclusion. A universe built on atoms. Atoms are the fundamental building blocks of the universe, the tiny particles that make up everything we see and touch. From the smallest grain of sand to the largest star, atoms are the common thread that connects all matter. Understanding atoms is essential for comprehending the workings of the universe, from the formation of stars to the functioning of our own bodies. As we continue to explore the subatomic realm, we unlock new secrets about the nature of reality and open up new frontiers in science and technology. The study of atoms is a journey into the heart of matter, a quest to understand the fundamental ingredients that make up the universe and our place within it.